This is an extremely tiny computer consisting of 8 electrodes. What if I told you it wasn't connected to a silicon board, but rather to brain cells? This is what researchers with Swiss biotech startup FinalSpark say is their new biocomputer, one that mimics the neural network of the brain and could be the future of computing.
Hey everybody, welcome to Studio 64. My name's David. I've been searching the interzones for some more science, space and tech news to share with you. And I found this over at Science Alert. This should be interesting. Swiss startup connects 16 human mini brains to create low-energy biocomputer. Wow. Okay. This. Image of translucent cells with copper-coloured electrodes attached. Bloody hell. I read about this growing up with science fiction and now we're actually making it real. Again, I'm not a bioelectronicist or tronicist.
Oh, bitch, use your words!
I can't even pronounce it, but that's fascinating to me. Well, as I say, all the sci-fi growing up with as a kid's now coming true. It's amazing. Computer scientists have for decades been vying to emulate the human brain, replicating its neural networks to build artificial intelligence or AI with enhanced processing power. But the more sophisticated those artificial neural networks become, the more powerful they get, and the more we rely on them, the more energy they consume. Yeah. And sometimes nature's original design is just better in some regards. Yeah. These AI companies, are building their own power bloody stations like Google and things like that. Because even just back in the day with Google searches to power the server farms, all the computers, they had to build their own power stations. AI is exponentially greater. So you've got these artificial intelligence companies, or component manufacturers like NVIDIA, particularly for their cloud services, AI cloud services and things like that, are building their own power stations. It's absolutely fascinating to me, This just incredible. And as usual, I'll leave the link to the main article below the video so you can pop in, check out these embedded links, go for a bit of a deeper dive if you want. Makes for an interesting read beyond the main article, believe me. All right, so in the latest demonstration of nature's efficiencies, a Swiss startup company has just launched a biocomputer that connects to living, pulsing brain cells, and according to its makers, uses far less energy than traditional bit-based computers as a result. Dear Lord. Rather than merely integrating biological concepts into computing, FinalSpark's online platform taps into spherical clusters of lab-grown human brain cells called organoids. A total of 16 organoids are housed within 4 arrays that connect to 8 electrodes each and a microfluidic system that supplies water and nutrients for the cells. Absolutely incredible. And I thought Elon Musk's Neuralink was amazing. This is really fascinating, although thinking about it definitely hurts my brain.
My brain hurts!
Incredible. The approach known as wetware computing, in this case, harnesses researchers' abilities to culture organoids in the lab, a fairly new technology that allows scientists to study what are essentially mini replicas of individual organs. Now, the rise in organoids as a popular research technique comes at a time when artificial neural networks, which underpin large language models such as ChatGPT, have also exploded in use and processing power. Wow. So FinalSpark claims that so-called bioprocessors like the brain-machine interface system they're developing consume 1 million times less power than traditional digital processors. And can you imagine in the future if we could connect this and do this sort of thing to damaged areas of the human brain? Again, I'm not a biologist, I'm not a neuroscientist, I'm not a computer scientist, but I'm thinking it's a possibility. Anybody knows more about it? Do you think that's the way the future could go? I'm just thinking beyond what we've got here at the moment. That's what a lot of people don't realize. They look at a prototype, which is like a proof of concept or a little prototype, proof of concept before a prototype, and they think that's not possible. Look towards the future. It's just one possibility among many. Fascinating. Look at this. Brain cells cluster together to form organoids, which are placed in arrays connected to electrodes. Wow, from Jordan et al. Frontiers in Artificial Intelligence. Holy God. Look at they're growing them up here on this top row here. NSCs, week 0, week 1 difference, week 2 difference, week 5, week 8, week 56. Holy crap. Circular membrane with whole layer of medium neurosphere electrodes. Dear God, this is incredible. As I say, I've got a basic idea in my mind of what I'm looking at. I'm not an expert in these areas, but this is just, I remember reading about this as a kid and the possibilities, and everyone laughed at it, and now we're actually doing it. Again, very early stages, but this is a start, and this is incredible. As I said, I can see going down a path where damaged areas of the brain could be, perhaps repaired. Who knows what the future will hold? Incredible. Now, while we don't have any numbers on their specific system, its energy usage or processing power, Final Spark's research team says that training a single large language model like GPT-3, a precursor to GPT-4, required 10 gigawatt hours, or about 6,000 times the energy that one European citizen uses in a year. Amazing. Meanwhile, the human brain operates its 86 billion neurons using only a fraction of that energy, just 0.3 kilowatt hours per day. That's amazing. Incredible. All right, well, look, there's a little video here. Said this biocomputer is a neural network of 16 tiny human mini brains. I think we should have a look at this. This looks intensely interesting, and then we'll carry on the conversation when we come out the other side.
This is an extremely tiny computer consisting of 8 electrodes. What if I told you it wasn't connected to a silicon board, but rather to brain cells? This is what researchers with Swiss biotech startup Final Spark say is their new biocomputer, one that mimics the neural network of the brain and could be the future of computing. The biocomputer doesn't simply use brains as a template. Rather, Final Spark has lab-grown human brain cells to implement into the device. Each of these 16 organoids, as they call them, are connected to the electrodes in a fluid system, which feeds the cells. It's a wild concept. However, the biocomputer uses significantly less energy as it mimics the efficiency of the brain, with the researchers saying it consumes 1,000,000 times less power than traditional digital processors. For reference, Final Spark says that to train an AI model like ChatGPT, it required some 10 gigawatt hours, the equivalent of 6,000 times the energy usage of a single EU citizen for a year. Science Alert reports that the human brain only uses the equivalent of 0.3 kilowatt hours per day, a fraction of that. Final Spark says that its biocomputer can currently be kept alive and computing for 100 days, with scientists already using its organoid brain for research purposes.
Wow. This is an incredible leap forward, isn't it? Yeah, I just think it's amazing. Definitely share your thoughts down below. Love to hear from you. Yeah, look at that. As I said before, meanwhile, the human brain uses 86 billion neurons using only a fraction of that energy. It's just 0.3 kilowatts per day. And yet GPT-3, before GPT-4, 10 gigawatt hours, or about 6 times the energy that one European citizen uses in a year. Incredible. Mind-blowing. Technology trends also indicate that the booming AI industry will consume 3.5% of global electricity by 2030. Already, the IT industry as a whole is responsible for around 2% of global CO2 emissions. Yes, I always found that mildly entertaining. When you'd see at the bottom of an email, it says, please don't print this email. Think of the environment and your CO2 emissions. You are aware that every time you do a Google search or send that email, that one of Google's server farms goes into basic meltdown because we do so many searches and so many emails a day in order to process this stuff that, as I said before, they've got to have their own power stations, and 9 times out of 10 they're coal. That's why it always fascinated me about that email, the email footer. Fascinating. Clearly, it's becoming increasingly necessary to find ways to make computing more efficient, energy efficient, and the synergies between brain cell networks and computing circuits are an obvious parallel to explore. Now, Final Spark is not the first outfit to try connecting probes to biological systems or attempt to reliably program neural networks so they perform specific input-output functions on command. Now, in 2023, researchers in the United States built a bioprocessor that connected computer hardware to brain organoids, and the system learned to recognize speech patterns. And again, we all know about Elon Musk and Neuralink, so that's a different thing. That's enhancing the brain, I guess. But I'm trying to point out the way things are going. Holy crap. Fascinating. Over the past 3 years, the Neuro platform was utilized with over 1,000 brain organoids, enabling the collection of more than 18 terabytes of data. Wow, that's actually pretty good. Final Spark co-founder Fred Jordan and his colleagues write in their published paper, which has been peer-reviewed like other scientific studies. So it should be, it's computer science. But as I say, there's the embedded link. Check the link below the video for the main article and go for your life. Check it out. It's very interesting. Absolutely amazing. Now, while the end goal may be new, energy-efficient computing approaches, for now, the system is being used to enable researchers to run lengthy experiments on brain organoids just like its predecessors. However, there are some improvements. The Final Spark team says researchers can connect to its system remotely, and the mini brains could be sustained for up to 100 days. Their electrical activity measured around the clock. 100 days, that's a good start. It's like nuclear fusion when we get a reaction running for 6 minutes. 6 minutes is useless. It was half a second a while ago, and before that it was impossible. 100 days, the next thing you know, it'll be 1,000 days, it'll be 10,000 days, and I'll be like a computer. Lifespan of 3 years or 5 years. That's what's going to happen. Interesting. Currently in 2020, actually, that would pose some very interesting ethical questions, wouldn't it? I mean, there are many ethical questions, but think about it. If you have a biocomputer, does it come under technological waste, or does it come under bio waste? You know, like when people have surgery and they get, like I've had, and had bits taken out of you. Is that a biohazard waste? And yet we have tech waste, like throwing a computer away. What laws are going to have to be changed to get away, and how would you dispose of them? Do you dispose of them do you separate the two components, and do you dispose one as biohazard waste and one as tech waste? Just thinking into the future and some of the issues that we can come up with. Very interesting. Anyone else got some other thoughts down there of what we could run into in the future with these? Just let me know. It's fascinating. Currently in 2024, the system is freely available for research purposes, and numerous research groups have begun using it for their experiments, Jordan and colleagues write. Now, in the future, we plan to extend the capabilities of our platform to manage a broader range of experimental protocols relevant to wetware computing, such as injecting molecules and drugs into organoids for testing, the team concludes. That could be interesting. Again, I'm not a biologist or a neuroscientist, but if we could set one of these things up, so for testing drugs and the effect on the human brain or human tissue, is that a possibility? Is that where we're going with this? Are they sentient? Will they eventually be sentient when you combine the two? There's another ethical consideration, plus the fact, are they considered alive, and are they an organic life form or a digital life form? Interesting. Whichever way this goes, aiding computing or organoid research, it'll be exciting to see what researchers can achieve. And the study has been published in Frontiers of Artificial Intelligence. So there you go. There's your link. So you can go and check this out on Frontiers of Artificial Intelligence, that embedded link. Absolutely and positively fascinating. That is just so cool. Again, sci-fi coming true. All this stuff I read about when I was a kid, and you see in Star Trek and all this sort of stuff, where people are getting parts of their brain, replaced with, like Elon Musk's doing with Neuralink, but also gel packs. There was, Star Trek, Voyager, part of the computing system was these gel packs, which were biological data transfer things that the computer used for processing information much faster than traditional computing networks. Fascinating. Absolutely fascinating.
Bioneural gel packs. Bioneural gel packs are a form of computer technology first developed for use by Starfleet in the early 2370s. The packs contain neural fibers surrounded by a blue gel with metallic interfaces on the top and bottom. They help store more information and operate at faster speeds than isolinear circuitry, which was the computer technology dominant throughout Starfleet earlier in the 24th century. The fibers of bioneural gel packs are capable of making billions of connections, generating an incredibly sophisticated and super responsive computing architecture.
All right, well, my name is David. Thanks for joining me for another Studio 64 Science, Space and Tech News update. If you enjoyed this video, please like, share, subscribe. I'd greatly appreciate it. And if you're up for it, drop a comment down below the video because I'd love to hear what you think. All right, take care, and as I always say, if you can't be good at it. And as I also always say,
I'll be back.